Hello everyone. Previous lecture we have studied the concept related with the chapter straight line, and in that we see the general form of a line. Here we know the general form of a line is always here ax plus by plus c is equal to 0. Remember this form? And we see some important definitions related with the general form of the line. Here we define firstly slope of the given line. Here slope of this line is always here minus a upon b. Then we see the x-intercept. Here x-intercept is always here minus c upon a. And in last, we define the y-intercept. Here y-intercept is a minus c upon b. So previous lecture, we see these three important concepts and we see some important examples related with this part. Now in today's lecture, we go with our new part in this chapter, and in that we consider the perpendicular lines and the parallel lines and some examples depending on this concept. Okay, so we go with our first part. Here in the first part we consider perpendicular lines. If two lines are perpendicular to each other, then the product of their slopes is always minus 1. Remember this part. I repeat again, if two lines are perpendicular to each other, then the product of their slopes is always minus 1. Let m1 is the slope of first line, m2 be the slope of second line, then here we get relation m1 into m2 is equal to minus 1. Remember, here m1 is the slope of first line, m2 is the slope of second line. If two lines are perpendicular, then m1 and m1 into m2 is always minus 1. Okay, then in second we consider the parallel lines. If two lines are parallel to each other, then their slopes are equal. Here again we consider slope of first line is m1, slope of second line is m2. If the given two lines are parallel to each other, then here m1 is equal to m2, that is here slopes are equal. Let us see some important examples related with this part. Let's go with our first one. Here in first example, if or here show that the lines 2x minus 4y is equal to 5 and 2x plus y is equal to 17 are perpendicular to each other. Okay, here again by using our first concept we have to show here the given two lines are perpendicular to each other. Again, to define this part we consider slope of the lines. Let m1 is the slope of first line, m2 be the slope of second line. Okay, let here m1 is the or be the slope slope of line here 2x minus 4y is equal to 5. Therefore, here m1 is equal to. We know if our equation is ax plus by plus c equal to 0, then here slope is minus a upon b. Here a is 2, b is a minus 4. So m1 is a minus 2 upon minus 4, and here we get 1 upon 2. Let m2 be the slope of second line, m2 be the slope of line here 2x plus y is equal to 17. Here again a is 2, b is 1, so slope m2, here m2 is a minus 2 upon 1 and is equal to minus 2. So here we get m1 and m2. Okay, let us consider product in between m1 and m2. Okay, so here in next we consider m1 into m2. We know m1 is a 1 upon 2. We know here m2 is a minus 2, and we know 1 upon 2 into minus 2 is always a minus 1. That is, product of the slopes is a minus 1. If product is minus 1, we directly say therefore the given two lines are perpendicular to each other. Okay, so very simple example it is. Directly by using the definition, what is directly by using this first point, we find or we show here given two lines are perpendicular to each other. Let's go with our second example. Here in second given, show that the lines x minus 2y minus 7 is equal to 0 and 2x minus 4y plus 15 equal to 0 are parallel to each other. Okay, again by using this second point, here we know if two lines are parallel to each other, then their slopes are equal, that is m1 is equal to m2. Using this part, here we show these two lines are parallel. Okay, so to define this part, we consider m1 is the slope of first line, m2 be the slope of second line. Okay, let here m1 be the slope of line here x minus 2y minus 7 is equal to 0. Therefore, here m1 is equal to, we know here a is 1, b is a minus 2. So here for m1, we have minus 1 upon minus 2 and is equal to 1 upon 2. Let here m2 be the slope of second line, m2 be the slope of line 2x minus 4y plus 15 is equal to 0. Therefore, here m2 is equal to, here again a is 2, b is a minus 4. So m2 is a minus 2 upon minus 4 and is equal to 2 upon 4. And we know 2 upon 4 is 1 upon 2. Okay, so here we get m1 and m2 are equal. Here m1 and m2 are equal. If these two are equal, given two lines are parallel to each other. Okay, so here we get m1 is equal to m2 and is equal to 1 upon 2. Therefore, the given two lines are parallel to each other. Again, very simple example it is. Directly by using the second part, we show here given two lines are parallel to each other. Okay, so we see some important examples related with this part. Let's go with our new part in this chapter, and in that we consider the point of intersection of lines. Okay, so here I write point of intersection of lines. Point of intersection of lines. Again, very interesting part it is. Here the coordinates of point of intersection of lines can be obtained by solving their equations. Remember, here the coordinates of point of intersections of lines can be obtained by solving their equations. Okay, so to find the coordinates, we solve our equations. Let's go with our examples. Here in first given, find the coordinates of the point of intersection of lines x plus 2y minus 3 equal to 0, and here 2x minus y is equal to 1. Here this is equal to 1. Okay, so here we consider our given equations or given lines. Here given equations are, here first x plus 2y minus 3 is equal to 0 is the first one. I write this as x plus 2y is equal to 3. Then here in second given 2x minus y is equal to 1. Let us consider this as 1. Here second as here 2. We have to solve these two equations. After solving these two equations, we get the values of x and y, and here the order pair xy is for the point of intersection. Okay, so here we solve these two equations. Let's multiply here first equation by 2. If we multiply first by 2, here we get 2x plus 4y is equal to 6. Then here second equation as it is, here given 2x minus y is equal to 1. Let's solve these two, or we subtract first from second one. Okay, so here subtracting 2 from 1, we get, okay, here we get 5y is equal to 5. Okay, then we get here y is equal to 1. Let's replace, or we put value of y in the second equation to find the x. So from 2, here we get 2x, and 2x is here 1 plus y. Okay, and this is equal to here 1 plus, we know y is 1, therefore here x is equal to, or this 2x is equal to 2, and in last we get x as 1. Here we get x as 1. Okay, so here we get the point of intersection. Therefore the point of intersection is point of intersection is here having 1, 1. So this is point of intersection. Let's go with our second example. Here in second, given example second, here given, show that lines x minus 2y minus 7 is equal to 0 and here 2x plus y plus 1 is equal to 0 are perpendicular to each other, perpendicular to each other. Also find the point of intersection of lines. Okay, again very interesting example it is. Here firstly we have to show whether the given two lines are perpendicular to each other, and to show here we consider slope of the given lines. Let m1 be the slope of first line, m1 be the slope of line here x minus 2y minus 7 is equal to 0. Okay, so here m1 is equal to, here we know a is 1, b is minus 2, so m1 is minus 1 upon minus 2 and is equal to 1 upon 2. Let us consider slope of second line is m2. Okay, so here I write let m2 be the slope of line, second line is 2x plus y plus 1 is equal to 0. Therefore here m2 is equal to, here we know m1 is a is 2, y is 1, so m2 is minus 2 upon 1 and is equal to minus 2. Now here we know m1, we know m2. Now we consider product in between m1 and m2. So we consider m1 into m2. This is equal to, we know m1 is 1 upon 2, we know m2 is minus 2, and this is equal to minus 1. That is product of product in between the slopes is minus 1. If it is minus 1, we directly say therefore the given lines are perpendicular to each other, perpendicular to each other. Now here we have to find the point of intersection of lines, and here to find the point of intersection we have to solve these two equations. Okay, let us consider first equation. Again consider here in the first given x minus 2y minus 7 is equal to 0. Here I write this as x minus 2y is equal to 7. Let us consider this as 1. Here in second given 2x plus y plus 1 is equal to 0. Here I write this as 2x plus y is equal to minus 1 and this is 2. Let us solve these two equations. And here to solve, firstly we multiply the first equation by 2. Okay, so we multiply first by 2, then here we get 2x minus 4y is equal to 14. Here second equation as it is. Here in second given 2x plus y is equal to minus 1. Okay, here we consider subtraction in between 1 and 2. Okay, so we subtract 1 from 2. Okay, so here we get, if we consider the subtraction, here minus of plus is a minus, here minus of minus is a plus, and here we get minus 5y is equal to 15. And here we get y is equal to minus 3. Here y is minus 3. Okay, so here we get y as minus 3. Let's put this value of y in the first equation to find x. So from 1. 1. Here I write x separately as 7 plus 2y. This is equal to, here 7 plus 2 into y is minus 3. Then is equal to 7 minus 6 and is equal to 1. So here we get the point of intersection. Therefore, the point of intersection is, here I write the final answer. Therefore, the point of intersection is having here 1 minus 3. Here is having 1 minus 3. So in today's lecture, we see some important examples related with the part. Here we consider perpendicular lines, we consider parallel lines, and we see some important examples related with the point of intersection. Thank you.